Hello, if you are asked to solve for x in this nice Olympiad math question, what will you do first? We are given 4 to the power of x equal to 20. If I decide to arrange both of them to become one common base so that I can simplify, we can see that 20 cannot come to be of the same base with 4. So what do we do? One thing that should come to our mind is the use of logarithm, either a natural logarithm or the use of logarithm. Now let's look at logarithm. As we do that, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. So what we're going to do now is to take the log of both sides. Now, if we take the log of both sides, we should be able to be arriving at a solution to this question. We have the log of 4 to the power of x equal to the log of 20. So if we have gotten to this point, in the next step, we can simplify. Knowing that this multiplicand will come over here and the power will come over here, and that will become x of log of 4. This will be equal to the log of, I will expand this to become 4 multiplied by 5, because 4 multiplied by 5 is 20. So if I expand that, I'll simply want to do one common thing. And what is that common thing? I'll have to divide both sides by 4 so that I can simply have one expression for the logarithm. So if I divide both sides by log of 4, if I divide both sides by log of 4, I can simply have x on the left hand side, and that will simplify the expression. While log of 4 cancel out log of 4, in my next step, I'll find out that my x will be equal to the log of 4 multiplied by 5 divided by the log of 4, and that will be the value of x. But that's not the solution, because I can simplify this further. Remember the laws of multiplication of logarithm. If I have the log of AB, log of AB can be equal to the log of A plus log of B, right? That's the multiplication law of logarithm. So that means I can expand that to make my x to be equal to the log of 4 plus the log of 5, and all of these can be divided by the log of 4. Great. Now in the next step, I can simplify this. If I simplify this, I'll have my x to be equal to the log of 4 divided by the log of 4, and this will be plus log of 5 divided by the log of 4. So from here, what will happen? Log of 4 will cancel out log of 4, and that will give us 1. And the value of our x will now be equal to 1 plus the log of 5 divided by the log of 4. This is not the solution, as I can still divide this expression to each more simpler term. We'll have our value of x here to be equal to 1 plus log of 5 divided by the log of 4 can simply give me 2 square, right? Good. So if I simplify that using log, I'll have my x to be equal to 1 plus log of 5 divided by 2 log of what? Log of 2. And so that expression can be simplified further to give me x equal to 1 plus, this is going to give me 1 divided by 2 log of 5 divided by the log of 2. Great. Now at this point, I can simplify using the log rule. Recall one log expression that if I have the log of A dividing the log of B, this one log rule, that this can be equal to the log of A base what? Base B. Why the denominator becomes the base, the numerator becomes the log. So I can apply it over there to make my x to now be equal to 1 plus 1 divided by 2 log 5 base 2. And that becomes the solution to that mass expression given to us up there. So the value of our s is equal to this. So if we compare this to the question given to us, we can truly verify to find out if our solution is right. We are given 4 to the power of x equal to 20. If given 4 to the power of x and we insert this into that expression, are we going to get 20? We're given 4 to the power of x equal to 20. So if I insert my 4 to the power of x to that expression, can I get 20? 4 to the power of x is 4 to the power of 1 plus 1 divided by 2 log of 5 base 2. If I simplify this, will I be able to have 20? Let's check this out. So if we simplify this using the principle of indices, we can find out that that whole expression can be simplified to give us, since this is an additional sign, this, remember this law of indices, that if you have a to the power of x plus y, and this can be equal to a to the power of x multiplied by a to the power of y, right? So if I apply that here, I can have my 4 to the power of 1 plus 4 to the power of 1 divided by 2 log of 5 is 2, right? And this will it give us 20. Now let's check out that. If we check out that, we'll have our 4 to the power of 1 plus, this is going to give us 2 to the power of 2, which is still 4, multiplied by 1 divided by 2 log of 5 is 2. Would this be equal to 20? From this expression, 2 can cancel out 2, and then we'll have our 4 to the power of 1 plus 2 to the power of log of 5 is 2. Would this be equal to 20? If you have the eye of a mathematician, you should be seeing the result out. This is going to give us 4 to the power of 1 plus, remember the law of logarithm. If I have a to the power of log of y is a, this can just simply give me y. Why? Because a will cancel out a and my result will be y. So if I apply it this way, I'm going to have that expression 2 cancelling out 2, and then my result there will just be what? 5. Now with this multiplication give us 20. 4 times 5 is going to give us 20. So 20 is equal to what? 20. So from that expression, we can see that the result which is x equal to 1 plus half log 5 is 2, is the correct solution that satisfies that expression given to us up there. Very easy and straightforward. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.